Good morning. Today we are going to use what we know about factors to find the longest factor string. In mathematics, we call that factorizations. Strings of factors are called factorizations. The longest possible factor string for 840 is made up of prime numbers. This string is the prime factorization of 840. You can use a shorthand notation to write prime factorizations. For example, you can write 840 as 2 times 2 times 2 times 3 times 5 times 7, or we can use that notation, the shorthand notation, which we call exponents, to stand for the 2 times 2 times 2. To represent 2 times 2 times 2, we're going to say 2 to the third power, right? So, or we can even say cubed. So it's 2 to the third power, or 2 cubed, times 3 times 5 times 7. And if you were to work out that multiplication, you would get 840. And as it says right here, the small raised number is called an exponent. An exponent tells you how many times a factor is used. For example, the prime factorization of 840 uses the number 2 3 times. So 2 times 2 times 2 is 2 to the third power. So that small number up there tells you how many times you're going to multiply that number by itself. And in this case, it's telling us how many times 2 will appear in that prime factorization. In the product, 2 to the third power times 5 to the fourth power, the exponents mean use a 2 3 times as a factor and use a 5 4 times as a factor. So you can take a look here. And of course, this is found on the first page of your book, which is page 46, the first page of this investigation, I can say, investigation 3.2, finding the longest factor string. So you can find this page and you'll see that 2 to the third power times 5 to the fourth power is actually 2 times 2 times 2 times 5 times 5 times 5 times 5, which would give us 5,000. So we're looking at these exponents to see how many times each of those numbers show up in that prime factorization. This means that you can write the prime factorization of 5,000 in two different ways. You can use expanded form, and I know you've used expanded form when you've written out numbers using expanded form. And then you can use exponential form, and that is when you are implementing those exponents, those little numbers at the top, to show how many times that number is showing up in the prime factorization without having to write the number that many times. So we can see that 2 shows up 3 times, so it's 2 to the third power. 5 shows up 4 times, so it's 5 to the fourth power. However, if you were to multiply 2 times 2 times 2 times 5 times 5 times 5 times 5, you would indeed get 5,000. So let's take a look at some different ways that you can read. You heard me say to the power of. So this one here is 3 to the power of 2. Or, oh, they're saying the second power. Okay. 3 to the second power. That's another way to say it. So 3 to the second power, or 3 squared. You remember that probably from when you learned about getting the area of probably just rectangles at this point. I don't think you guys did circles yet, but anyway, so getting that area of a polygon or of a rectangle, you used squared when you gave your answer. So you probably put the area is 5 or 52 square inches, or inches squared. So here we've got a 3, right? So we say 5 to the third power, or we could say 5 cubed. You would use this when you are getting the volume. We have not done that yet here in our class, but you probably have worked on volume last year, where you would say, once you got the volume of something, you would call it cubic inches or cubic feet. You could have cubic meters. So that is to the third power. And then here we've got 2 to the fourth power, or 2 to the power of 4. So those are the two different ways that that you can say those out loud. but they all mean the same thing. This is 3 times 3 because it's 3 to the second power. This is 5 times 5 times 5 because it's 5 to the third power. And this one here is 2 times 2 times 2 times 2, 2 to the fourth power. All right, so in today's problem, you're going to find the prime factorization of numbers. You will use the factorizations to answer questions about factors and multiples. And what I'm going to do is post a video from Khan Academy. I really like the way he breaks down one strategy that you can use to find the prime factorization. So that's going to be posted to help you. And I'd like you to solve this problem. We're doing A, B, C, and D. You do not need to complete E, and I will let you know what your homework is, which are going to be these ACE problems. I just need to come back over here for 1 second and grab which ACE problems we'll be doing, which is right over here. So your ACE problems, and again, this will be on the Google Classroom, but it's going to be numbers 5 through 20 only. So ACE assignment is numbers 5 through 20. I'll get you those exact page numbers. It's going to be the ACE problems that come after investigation 3. So I'll go ahead and list those on Google Classroom. So you work on the problem and do ACE problems 5 through 20. And please come to office hours if you have any questions.